Nutrigenomics and Metabolic syndrome. What do you know about them? Nutrigenomics is study of the effect of nutrients intake on individuals' genetic makeup. For example, the effect of high macronutrients intake on diabetes mellitus. What about metabolic syndrome? Metabolic syndrome is groups of non-communicable diseases that occur together, usually derived by unhealthy food choices, eating routine, and positive energy balance. Now, you get the idea how nutrigenomics correlate them and promote healthy event. I will let my group mates explain more about them.
Next, moving on to lifestyle-associated metabolic diseases. Lifestyle-associated diseases are the type of diseases that are caused by human life adopting an unhealthy diet, lifestyle, and living environment over a long period of time. These diseases are non-infectious or non-communicable and have slow progression. It was reported that 60% of deaths worldwide were due to lifestyle-associated chronic diseases, which is double than infectious diseases. Examples of this type of diseases are cardiovascular, nutrition-induced cancers, diabetes, renal failure, and hypertension, and almost all these diseases share similar risk factors.
Next is nutrient interaction in diabetes. Diabetes mellitus is a complex metabolic disease with a lifestyle component that is characterized by changes in insulin secretion, function, or both, leading to hyperglycemia. As you can see at the table, the progression of the disease is significantly influenced by a number of variables, including genes and food, metabolic profile, environmental changes, and their interactions. Exploring how the three components affect gene function has made substantial use of omic approaches.
Next is flavonoids interaction with type 2 diabetes. Many plant foods are rich in flavonoids. The three flavonoids include flavon, flavonols, flavonones, isoflavones, and anthocyanins. Studies have shown that anthocyanins and anthocyanidins stimulate insulin secretion and have protective effect on cell in vitro by stimulating important factors for insulin gene transcription and upregulating gene encoding for GLUT4 transporter, which is SIC2A4 gene.
Evidences show that dietary fats, a major macroenergy nutrient, effectively maintain the balance between lipogenesis and fatty acid oxidation in human body. Certain dietary fatty acids also affect cell metabolism and gene aspiration in an array of metabolic disorders. However, high-fat diet intake is associated with high risk of type 2 diabetes mellitus, as an elevated level of palmitate inhibits the glucose-induced insulin gene expression, thus resulting in the decreased secretion of insulin from red islets. Anyway, lactic acid is known to improve glucose metabolism in type 2 diabetes mellitus, as in an animal models, it decreased the blood glucose level and enhanced the insulin-stimulated glucose uptake into muscle through GLUT4 receptors.
For the application of nutrigenomics in preventing cardiovascular disease, most likely normalization of altered intermediate CVD phenotypes comprising information regarding biological gene-diet relationships will be one of the earliest use of nutrigenomics in cardiovascular medicine. Therefore, it is crucial to gather a number of thoroughly verified gene variations linked to intermediate symptoms of CVD across the population. This will make it easier to identify those who are genetically predisposed so that dietary therapies can be done successfully. Transcriptomics, proteomics, and metabolomics will help to clarify the molecular mechanisms behind gene-diet interactions in this process.
Next is nutrient-gene interaction in cardiovascular disease. First is gene interaction with polyunsaturated fatty acid. Apolipoprotein APOA1 is a component of HDL. PUFA can modulate factors in metabolism of carbohydrates and lipids and reduce the LDL cholesterol level in patients. Second, lipoxygenase regulates synthesis of leukotrienes, inflammatory cytokine. Omega-3 PUFA diet is shown to nullify release of leukotriene production by proliferation of PPAR gamma and endothelial cells. Next, endothelial nitric oxide synthase generates nitric oxide from L-arginine in blood vessels. It reduces the risk of atherosclerosis. Entry-PUFAs improve NOS expression, leading to vasodilation and lower circulating markers like isolactin, intercellular and vascular cell adhesion molecule.
In a nutshell, the science of nutrigenomics continues to spark a lot of interest and engagement with the hope that many health inequities can be avoided. Some examples of the current way of life include changes to the nutritional system and an improvement in economic status. This shows that nutrigenomics could have significant impact on society from medicines to agriculture and dietary practice. The understanding of the human genome has advanced significantly along with the numerous transcriptomics, genomics, metabolomics, and other omics that have brought nutritional experts to address the difficulties that have been posted. I think that's all for me. Thank you for watching this video.